What's dark matter? Dark matter. Okay, dark matter is. So first of all, how did the idea of dark matter come about? It came about through observational evidence. In the early 20th century, it was discovered that the Milky Way was not the universe. We had faraway objects way beyond the Milky Way, stars, galaxies, etc., mainly galaxies. And then it was discovered that the galaxies are receding away from us. They are moving further and further away from us. So there's redshift and all that we discovered. And then we discovered that when we observe galaxies, when we take spectrometric measurements of the light coming from the galaxies, then you will find that one end of the galaxy, let's say it's a spiral galaxy, one end of the galaxy, the light coming from there will be red shifted and one end will be blue shifted. So we know that galaxies are rotating. And based on the redshift and blue shift, we can determine at what speed the galaxies are rotating. And then you can calculate the amount of mass inside a galaxy by computing its luminosity. So we know how much mass is in a galaxy. We know at what speed it's rotating. And then you find that the rotation of speed of the galaxies that we observe, it doesn't match the amount of matter the galaxy contains. It's rotating way faster. Why is that? That can only be explained by saying that the galaxy has way more mass, but we can't see it. And we find that in most galaxies. These are called rotation curves. We find that galaxies rotate faster than they should be rotating based on how much the amount of matter we see. So there is clearly some kind of unseen matter inside these galaxies, or that's part of the galaxy, but we can't see it. And that's how the concept of dark matter came into existence. So we now know that most galaxies have this phenomenon. And if we add everything up, we find that uh, about 24% of the mass energy of the universe, roughly 24-25%, is made of dark matter. Only 4 or 5% is visible matter. Everything we see in the universe, stars, galaxies, nebulae, whatever, dust clouds, everything that is luminous makes up only about 5% of the mass energy of the universe. About 25%, roughly, give or take, is dark matter, and about 70% is something called dark energy, which is even more mysterious. But anyhow, that is what dark matter is, and there are lots of theories about what dark matter could actually be. It is clearly it could be some class of particles. There is modified Newtonian dynamics also, MOND, which kind of gives you a solution for this without having to uh, postulate or theorize uh, that there are classes of particles out there, dark particles. But if you set aside MOND, the theories are that dark matter could be various classes of particles. Either particles that are purely gravitating in nature, purely gravitational, they only interact via gravity, not via the electromagnetic force. Or maybe these particles could also have the weak interaction. So there are lots of different classes of particles that have been proposed, like WIMPs and machos and axions and strangelet, primordial black holes, stable quantized bound states of primordial black holes, much more. So that is what we understand of dark matter. We have zero observational evidence thus far of any of these particles. There are certain experiments that are running, and some experiments give you some telltale signs of something out there, but it is still under dispute. So we still don't have any answers. So that is essentially what dark matter is.